Okay, so now we're going to start talking about logarithmic functions. Remember we had something like x equals b to the y, and that was a problem. We said, oh, we want to switch x and y, and now we want to solve for y, and that was a little bit of a situation. Okay, so logarithmic functions, the definition says this. It says if you have y equals log base b of x, okay, that is equal to, or is equivalent to, and the symbol for that equivalent sign is like this. And then the two arrows mean you can go either way. B to the y equals x, okay? So those two statements are saying the same thing. They're just in different forms, okay? Now, we do have some restrictions. B has to be greater than 0, and b cannot equal 1. Okay, that's the restrictions we had when we had an exponential function. X also has to be greater than 0. Okay? Okay, so right here, this is big. This is half the battle of working with logarithms. It's a new function that we have, but we run out of different types of notation. And so we use this abbreviation, log, to say, hey, we have a function here. It's the logarithm, and then that little superscript, a subscript. It's a subscript b. You got to write it down a little bit below the g, okay? And then x is what we call the argument. It's what we're taking the function of. Now, a lot of times books will put parentheses around that. When you put in your logarithms in your calculator, like on my calculator, it automatically opens a parenthesis. Okay, so just be aware of that when we go to use our calculators, which we will do. But this is not it doesn't have anything to do with the b. I mean, it's a value independent of b. Sometimes students think, oh, it's like a little exponent, but it's not, okay? This is the argument. It's what you're taking the logarithm of, okay? All right, so now let's talk about these two forms a little bit more. One form, the logarithmic form, says y equals log base b of x. And if you want to put parentheses around it, sometimes I think it's more useful to see that. You could also write it the other way, log base b of x equals y. Now, I don't always put the parentheses in like that, but like I said, it might be helpful for you to see that. A lot of times I write my logarithms with the log on the left, okay? That's just what I like. Okay, but what we have to know is what some of the parts mean. This b is the base. Remember that constant we had, like we had a base 2, or we had a base of 1/2, or a base of 3, or something like that. Remember, the b has to be positive, and it can't be 1, okay? All right. The y that I'm pointing to here with this arrow, the y, that's the exponent. A logarithm, then, is representing an exponent, okay? All right. In exponential form, b to the y equals x, that we're a little more used to seeing because we've had exponential functions, right? Okay, so the b is the base and the y is the exponent. Okay, and remember these two statements are equivalent, meaning you could write it in exponential form or you could write it in logarithm form. It's kind of like, you know how when you have 1/2, we say, oh, that's a fraction. Or we could write it as 0.5, right? That's in decimal form. So it's just a matter of which form do we want it. Sometimes we like 1/2, sometimes we like it as a decimal. Just depends on what we're doing. Okay, so that's kind of what happens here with logarithms. We have the form for the equation, and these are equations, right? You have the form in exponential form, but we also could write it in logarithmic form, okay? And they're both equations. All right, so one of the things we have to be able to do is we have to be able to go between the two forms. So it says write each equation in its equivalent exponential form. So they're going to give us the logarithm. We're going to write it as an exponent. Okay, so where can I write something? So if I have log base b of, let's see, what do I want? We've been using x, right? Equaling y. Then I write that as b. You take the base, so you start down here. You go across and get that exponent, b to the y, and it equals the argument, equals x, okay? That's how you do it. So it's you start down here at the base, you go get the exponent, and then you go over and you pick up the what it equals. Some people tell me that's a snail. If you want it to be a snail, it can be a snail. Okay, but we'll practice. So here you have this time they wrote it the other way. So for this first one, I'm going to write it this way so you can see it. Now they did not put parentheses around the x, but you could. All right. So the base starts here, 5. You go across and get the exponent, 2, and it equals the argument, x. Now you could finish that off and say, oh, x equals 25, because we know what, 5 squared is. But I don't think they want that. They just want it in the equivalent form. So they probably just want that. Okay. Now this time I won't switch it. We'll just make our snail face the other direction. You're going to start with the base, b. You're going to go over here and get the exponent, 3. And it's going to equal the argument, which is 64. Okay, so it's not super complicated, but it does take a little while to get used to it. You start with the base, always start with the base, 3. Go on the other side of the equal sign to get the exponent, y. And it equals whatever you were taking the logarithm of, it equals 7. Okay, so when we're looking at this, we're saying log base 3 of 7. Okay, so you're taking the logarithm base 3 of 7. Okay, I hope that helps. And that's how you switch from logarithmic form to exponential form. And then we're going to have to switch the other way too.